Hello everyone. Hello again everyone. Welcome to our discussion of section 12.2 where we will talk about the arithmetic sequences and their partial sums. So last time, as you recall, we discussed sequences and we even talked about a specific sequence called the recursive sequence. This time we will talk about another type of sequence which is called the arithmetic sequence. So just to begin with, let's briefly describe what these kinds of sequences are. Such that, let's say, the terms of it, such that the terms are, say, A plus D, and we will have more to say about this D. A plus 2D, A plus 3D, A plus 4D, and so on and so forth. Where A, that term, is the first term in the sequence, and D is called the common difference. Once you see one example, you know exactly what that common difference is or does. And the nth term in the sequence can be determined using this nth term of a sequence formula, which is A sub n, right? Last time we learned what that is, right? That's any term in the sequence, because n is left free, and then once you decide that this is A2, this would be the second digit in the sequence, or A10, that would be the 10th digit in the sequence, equal to A plus n minus 1 times D. Okay. So just let's briefly define each of these. We have A sub n. That's nth term in the sequence. And we've already defined A and D, right? So let's just define, for the sake of this page only, the variable n also, which, as you know, it's the location of the term. So the location of a term in the sequence, whether it's the 5th place or 10th place or 15th place, that would be the variable n. Okay, so let's have a look at a couple of examples just to get a better understanding of what arithmetic sequences are. So the sequence 2, 5, 8, 11, 14. Dot. So this is another infinite sequence. It's an arithmetic sequence. So here, the common difference, or D, is 3. Because if you take any two consecutive digits in this sequence and you find the difference, it's going to be 3. And you always take the next digit and you subtract the previous digit from it. So let's take these two, and D is 5 minus 2 equals 3. We can take those two, and then 8 minus 5 equals 3. Do you see how it works? And that's D. So this is, once again, is D. 11 minus 8, or D, that's 3. And 14 minus 11, or D is equal to 14 minus 11, or again equals to 3. So that is D. It's simply the difference between any number and the digit before it. And it's always the same. It's the same number for the same arithmetic sequence. So if you have another arithmetic sequence, then D could be anything. Okay? And D could be a negative number. So suppose if these were reducing numbers, so if this was going from 2 to, say, -1, and then from -1 to -4, then -1 minus 2, that would be -3. So instead of D being a +3, it would be -3. So common difference can be either positive or negative. As a matter of fact, let's do an example, or let's show an example like that very quickly here. And so you could have a sequence like this, 10, 0, -10, -20, -30, and this is once again an infinite arithmetic sequence. So then to find D, you can take the difference between these two numbers. So you can say D is equal to 0 minus 10. What would that be? Minus 10, right? So let's see if it's the same for these two digits. That would be D equals minus 10 minus 0, or minus 10, right? We can take the common difference between these two digits. It would be minus 20 minus 10, and so minus 20 plus 10, or minus 10 once again. So in each case, you can verify that the common difference is -10. Okay? So now that we've introduced arithmetic sequences, let's talk about their partial sums. Okay? So for the arithmetic sequence that we just mentioned, for the arithmetic sequence, and that we know of being of this form, of that form, using this formula. S sub n is equal to n times a plus an over 2. Okay. Okay, so let's define these variables where a is equal to the first number in the partial sum I hope you're catching the significance of this definition, because you're not, when you calculate the partial sum of an arithmetic, of any sequence, including the arithmetic sequence, you don't always start with the first digit in the sequence. You might start somewhere in the middle. So A is not the first digit in the sequence. Take a careful look at this definition. It doesn't say the first number in the sequence, it's the first number in the partial sum. So if you're adding digits 7 through 20, then the first number you include in this formula is the 7th digit. It's the 7th digit that you include here plus the 20th digit and then divided by 2. So it's very important for you to pay careful attention to this definition. A is not the first digit in the sequence, it's the first number in the chunk of numbers that you're calculating the partial sum for. So if you're starting to add, say, from the 21st digit to 30th digit, then A would be the 21st digit. Okay? And notice the definition for this one. This is the last number. A of n is the last number in the partial sum. And n, of course, in this case, n is not the location of a term. It's the total number of terms that are being added or summed. Okay, I hope you're catching all the nuances that exist in these definitions. So n is the total, unlike section 12.1 where we looked at n as being the position of each digit in the sequence, this is in here, in this formula, n is the total number of terms that are being added. How many terms are we adding? Are we adding 25 digits? Are we adding 12 digits? Are we adding 130 digits? N would be that number. So let's look at some examples. So here, with this sequence, a sub n equals 3 minus 4 times n minus 1, for this sequence, we want to list or find the first 5 terms, so A1, A2, A3, A4, A5, and state the common difference for this arithmetic sequence. Okay, so we already know that the common difference is -4. We can see that from the formula here, knowing that we're talking about an arithmetic sequence, but we can also find this -4 from the numbers that we have. Either way is fine. So for A1, we substitute wherever you see n with 1. So 3 minus 4. And when I said n is the total of number of terms that are being added, that's in this formula. Okay, in this formula, n represents that. But in this formula, n is once again the location of the number in the sequence. So times 1 minus 1. So this will be 3 minus 4 times 0, which is 3. A2 would be, plug in for n with 2, right? 3 minus 4 times 2 minus 1 equals 3 minus 4. 2 minus 1 is 1. Equals 3 minus 4 or minus 1. A3 is 3 minus 4 times 3 minus 1 equals 3 minus 4 times 2, right? 3 minus 1. And then 3 minus 8, right? That's the order of operation. Remember order of operation? So first we have to multiply, and then that is equal to minus 5. A4 would be 3 minus 4 times 4 minus 1. So 3 minus 4 times 4 minus 1 is 3 equals, so 3 minus 12, and this will be minus 9. One more number, and then we'll have to find the common difference. So A5 is equal to 3 times, plugging in there, minus 4 times 5 minus 1 equals 3 minus 4 times 4, right? 5 minus 1 is 4. 3 minus 16, and this will be minus 13, like that. And the common difference, you can take any of these consecutive. It has to be a consecutive digit. You can't find the common difference by finding the difference between the 4th digit and the 2nd digit. No. Any consecutive numbers you can use to find the common difference. Let's take, I don't know, let's take these two. Okay, so D would be, let's subtract A4 minus A3, right? So A4 is minus 9, A3 is, so minus, so this minus, minus, A3 is minus 5, and so we have minus 9 plus 5, or minus 4, and that is the common difference. Common difference there. Okay, let's see another example. So for the following sequence, which I will write down in a minute, we want to find the common difference the fifth term, the nth term, and the 100th term of the arithmetic sequence. Okay, so here's the sequence. We have 7 over 6, 5 over 3, and 13 over 6, 8 over 3, and this is another infinite sequence. Well, out of all of these, so the common difference is the easiest easiest number to find. So let's find that. So D would be the difference between, we already know this is an arithmetic sequence, so we don't have to show that there is a common difference. So let's take the difference of any pairs of numbers here. I'll pick the easiest pair, this one, because the numbers are easier to work with than 13 and 8. So we would say 5 over 3 minus 7 over 6, right? There is a common denominator here, which is 6. Now, this denominator is already 6, so we don't have to do anything to this fraction. This fraction is not there yet, so we need to multiply the denominator by 2 to get it to that point, right? To get this number to be the common denominator. But we can't do this to the denominator and not do the same thing to the numerator. So we're going to multiply the numerator by 2 as well. Then we get 10, right? Then because we now have common denominator 6 and 6, we can add or subtract the numerators. In this case, subtract, of course. So 2 times 5 is 10 minus 7. We have 3 over 6 or 1 over 2. So that is the common difference. Okay. Okay, so what else do we need to find? We need to find the fifth term. Okay, the fifth term should be easy to find because now, well, we can find the fifth term in 2 ways. We can either find the fifth term by adding 1/2 to this. We could do that, and it'll give us the fifth term. Or we can find the nth term, which we're asked to find, the nth term. We can find that, and then use that to find the fifth term. So let's do that. Let's, because we certainly know how to add these two and get the fifth term, right? But let's find the nth term of this sequence, and then we'll use that formula to find the fifth term. Let's do that. In fact, we don't really need to find the nth term before calculating the fifth term. We already know, so we know that arithmetic sequences have this form, right, which we introduced earlier. They have this form. an equals a plus n minus 1 times d. So let's use that. Let's use that to find the fifth term, because we already know what's the first term, which is 7 over 6. And then n would be 5, and d we know it's 1/2. So we can find a5. I do worry about if you don't keep track of what is happening to the same variable used in different formulas. I do worry about that. So here, in this case, in this formula, a is the first term in the sequence, the very first term. So that would be 2 here, that would be 10 here, and that's what that a represents. But in the next formula, when we talked about a being the first number in the partial sum, a, it's the same letter. And again, I'm using these because I want to be consistent with your textbook. But a here, in this formula, is not the same a as you have here. It just occurred to me to explain this. Okay, this a, sure, I'm using a because your book is using that, here and here. But please remember, these variables can be highly formula-oriented. So they mean it's the same letter, but they mean different things in different formulas. So please keep track of that. They may or may not mean the same thing. In this case, they don't mean the same thing. So a here in this formula is the first term in the sequence. But here it's the first number in the partial sum, which means it's not going to be necessarily the first digit in the sequence. That's what it means. It would be the first digit wherever you start adding numbers. That's basically what that a represents. So here, so we know that the arithmetic sequence has this formula. Right? We know that. Now we want to find the fifth term. Just use that. So we have a5, or the fifth term, is equal to the first term in the sequence. That is 7/6. Plus, we're finding the fifth term, so n would be 5 minus 1 times d, which we just found, which is 1/2. Okay? So let's do the basic arithmetic on this. This would be 4. 5 minus 1 is 4, times 1/2 is 2, right? So the denominator here is 1. What is the common denominator? 6, right? So this one is happy. This fraction already has the common denominator. This one doesn't. We have to multiply it by 6/6 to get this fraction to have the common denominator. So then we have 7/6 plus 12/6, right? And that'll be, let's see if I have, just want to make sure that, so yes, so that's correct. So we have 19/6. So the fifth term in this sequence is 19/6. Again, let me bring this back because I do worry about this. Notice here, we talked about n, right? Meaning different things in this formula than in this formula. I think that's clear now. But what about n? N also is the same letter, but in different formulas, it means different things. So here, n means is the location of a term in the sequence. just like what we used it here. If we are finding the 5th term in the sequence, n is 5. If you're finding the 60th term in the sequence, that would be 60 minus 1. But in this formula, n does not represent that. It's not the location of any number in the sequence. It simply is the total number of terms that are being added. So if you're adding 5 digits in the sequence, it's 5. If you're adding 27 digits in the sequence, it's 27, and so on. Okay? So again, whenever you're using these formulas, please pay particular and careful attention to what meaning they have in that formula. Okay, the other thing they're asking us to do here is find the nth term. So that was the 5th term. Now to find the nth term, they basically want us to find the formula for this sequence, because we have the digits given to us, but we don't have the formula for it. Last time in 12.1, we said why it's important to have that formula, right, for any sequence. First of all, you can program it into a computer if you want to perform any advanced calculations. Second, you don't have to list the numbers to get to that number that you're looking for. If you're looking for the 605th digit in the sequence, do you want to list all 604 digits before you find out what 605th digit is? No. So instead of that, you'll use the formula for it. So to find the nth term, we have an. I'm just going to use this to help me find the nth term. A is the first term in the sequence in this formula, so that's 7 over 6. And then plus n minus 1, so I'll keep that as n minus 1, times d, which is the common difference, which is 1/2. We found that. Okay, so we can leave it like that. Yeah, we can leave it like that, with everything showing as what they are, the common difference, the first digit, and that. Okay, so that's the nth term. And we were also asked to find the 100th term. So let's find that. Definitely we can use the help of this formula right now, right? So to find the 100th term, and this was the 5th term, the nth term, and the 100th term. We have A100, I'm just plugging in here, is equal to 7 over 6 plus 100 minus 1 times 1 over 2. Okay, so we have 7 over 6 plus, this would be 99 times 1/2, or plus 99 over 2. Once again, this is, we need to take the common denominator. The common denominator would be 6, right? Common denominator is 6, looking at these two numbers. This one is okay. We don't have to multiply this fraction by anything. But this one, we need to get it there, right? So to do that, we multiply it by 3 over 3. So 3 times 2 is 6. Now we can add the numerators. So we have 7 plus 3 times 99, it's 297, right? So let's double check. So 3 times 99. 3 times 99, 297, yeah. There you have it. Oops. I smeared my ink here, like that. And so we have that which is 304 over 6. These are both even numbers. Of course, we can simplify that. So we have 152 over 3. Can we simplify that anymore? No, that's as far as we can take it. So this is the nth, 100th term in the sequence. Okay, let's take a look at another example. So the 20th term of an arithmetic sequence is 101. Okay, that's the 20th term in the sequence. And the common difference is 3. And we want to find a formula for the nth term. All right? Okay. So here's the solution. So I recommend that you pause the video, answer the question on your own, and then come back to the video again after that. Okay, so I'm assuming you've done that. So the 20th term, or A20, we are told it's equal to 101. Okay, we are told that. We are also told that the common difference, or D, is equal to 3. And we want to know the nth term. So this nth term, that means what is A sub n. That's what they're asking us. So it's important to be able to connect that question to a notation we've been using in our formulas. So they're asking for that. Okay, let's write it out. We know that for an arithmetic sequence, A sub n, so let me write that this way. We know that for an arithmetic sequence, the formula is A plus n minus 1 times D, right? So what do we need here? We need the first number in the sequence, we need the common difference, and we need the, and then that. So can we answer this question right away? No. I mean, we have the D equals 3, right? We have that. N can be free in the AN formula. N can be left like that. But we need D, and we need the first digit in the sequence. We have D, but we don't have the first digit in the sequence. So how do we figure out what is the first digit in the sequence? Well, let's make use of that information. Okay, so we're going to use this information information to find A. Okay, and here's how we're going to do it. So we know that A20 is equal to 101. So then 101 equals A plus this is the 20th digit in the sequence, right? So n for that digit is 20. So 20 minus 1, and d is 3. So in this equation, we only have one missing piece, which is the first digit in the sequence, A. So we can solve for it. So let's do that. We have 101 equals A plus, that's 19. 20 minus 1, 19, times 3, that is 57, right? A plus 57. So A would be equal to 101 minus 57. Just doing the algebra on that, okay? So A is equal to 44. Okay. Okay, so now that we have 40, the first digit in the sequence, we can write down the nth term formula for this sequence. And so we have, so thus, A sub n is equal to 44 plus n minus 1 times 3, like that. Okay. I hope things are starting to make sense. The biggest thing here that I see could trip some of you, could cause difficulty with some of you, is that thing I mentioned earlier. Please just be aware of what these terms mean in different formulas. A and n mean a different thing in this formula than they mean in this formula, which is the partial sum formula for an arithmetic sequence. Okay? Just be aware of that difference there. Okay, let's do another example. So we want to, this time we want to find the partial sum, which means we're going to use this formula, right? Let me bring it back. Just a quick reminder, we're going to use this formula. This is the formula for the partial sum of an arithmetic sequence. Every different sequence will have its own formula for calculating the partial sum. Okay, this formula applies only to arithmetic sequences. So what are the given conditions? The given conditions are these. A is equal to 100. So that's the first digit, not in the sequence, in the chunk of numbers that we are adding. So that's the first digit in the partial sum, not in the sequence. So A is being given to us. And also D is being given to us as negative 5. And N is being given to us as 8. So we are adding 8 digits. That's what this is saying. Finding the partial sum for that. Okay, so first thing, we should remember the formula for the partial sum, right? Note that the formula for the partial sum is as follows. It was n times a, which is the first digit in the partial sum, plus an divided by 2, right? That's the formula we're using. So in this case, do we have a? Yes. Do we have n? Yes. Do we have an? No. So let's see. That satisfies the given conditions. So we should look for the 8th digit. So if this is the first digit in the partial sum, in this question, because they're not specifying which digit in the sequence this is, we have to assume that this is the first digit. So that would be the 8th digit in this case, because they don't provide us that information. They don't say if this 100 is the 50th digit or the 16th digit. So they don't specify that. We have to take this as the first digit. So let me state that. Because it is not mentioned that 100 is other than the first digit, other than the first digit in the sequence. We will assume that it is the first digit in the sequence. That would change this problem entirely if they said this is the 5th digit. If they said this is the 5th digit and A5 is 100, and we want to calculate the partial sum for 8 digits all the way to 13th, right? 8 digits, 5 plus 8. So all the way to 13th digit, that would change this problem from what you see here. So no mention is made that this is different than the first digit in the sequence, so we assume that this is the first digit in the sequence. And we're going to use that to find an, which would be, if this is the first digit in this sequence, then n equals 8 would make this A8. So let's calculate A8. Okay, thus, let us calculate A8, because we're going to need it for this formula, right? Okay, so A8 is equal to, let me move this up a little bit. A8 can be calculated using this formula, right? A plus n minus 1 times d. So this would be 100 plus this would be 8 minus 1 times d, which is negative 5. Okay, so we have 100. 8 minus 1 is 7 times minus 5 is minus 35. Right? So let's see. So minus 35. Like that. So 100 minus 35 is 65. So therefore A8 is equal to 65. Okay? We're going to need this because that would be here, the number we would use here. So now we can use this formula. Let me see if I can keep everything on the screen as I do this. Maybe I can. A little more like that. Okay, so now we can apply the formula here. So S8 would be equal to 8 times, right? 8 times A, which is 100, plus A8, which is 65, divided by 2. Okay, like that. So 100 plus 65 divided by 2, what is that number? Let's calculate it. We're just going to calculate this piece. So 165 divided by 2. So 82.5. Or we can do it this way. We can do S8 is equal to 8 times 165 divided by 2, or S8 is equal to 8 times 165 divided by 2, which is equal to, let's see, what is that equal to? Let me move this over like that. So 8 times 165, that is 1,320 divided by 2. Therefore, that divided by 2 is 660. So S8 is 660, like that. Okay. Let's do another example. So we have been given this time, we have been given the partial sum. So for an arithmetic sequence, so all of that is good information. That this is coming from an arithmetic sequence. -3 plus -3. I should have said minus, but it's okay. So let me put it in parentheses. So -3 halves, plus 0, plus 3 halves, plus 3, plus ... plus 30. Okay, that's what we have. It's given as that. So, okay, so here, what do they want us to find? Let's see, because in my notes, it doesn't say what it's asking us to find here. So partial sum. So we want to find, let's see, this is 23. D. So first let's find D, and then we'll figure out, because given as this, and then 30, that would be n partial sum, and so it's given as that, and of course then we have to find the 23 digits. Okay, so given this, we want to find the partial, find S23. I think that's what the question is asking here. So yeah, so we need that. And okay, so like that, and then let's see that and that. Okay, yeah. So we want to, given this information, we want to find the partial sum of the first 23 digits in this sequence, right? This is from here to here, it has to be 23 digits. We're not given all the terms in this partial sum, but we're looking for the partial sum of this arithmetic sequence. Okay, so what are the two formulas that we have to work with? Let's write those down first. So solution. Note that we have two formulas to work with, right? One of them is a sub n is equal to a plus n minus 1 times d. The other one is the partial sum formula, which is n times a plus a n over 2. Okay. So let's see. We have that. Let's see, given some like that. Okay, so to find S23, we can simply then, do we know the first digit in the partial sum? The first digit in the chunk of numbers that we're adding? Yes, we do. That's -3. Do we know an, or the last digit in the sequence of numbers we're adding? We do. That's 30. And do we know how many numbers we are adding? And so the partial sum. I see. So this part, guys, you're not seeing my notes that I have here, and these lecture notes are based on those. So apparently, the question, it says a partial sum of an arithmetic sequence is given as this. Okay. They don't tell us how many missing numbers there are here. And there's a piece of this that I have not written down in my notes, but let me correct this. So we don't know how many numbers we're adding yet. So this 23 is not there. Again, before I post these notes on Canvas, I'll go through and white out all of these scratch marks. So you won't see this on the lecture notes that I'll post on Canvas. But the question says, find the partial sum. Okay, so find, so that's the missing piece. That was the piece that was missing from my problem statement. So find the partial sum. So find, let me correct this by saying, I wonder how I can correct this so it doesn't make it too much of a mess. So find and this, please ignore this, find the partial sum of these numbers. Okay, so that was the question, not find S23. Okay, so now the problem with this question is that we don't know how many numbers we're adding. Okay, so that was a mistake that I had. S23, no. The question would have been too easy if it just asked, if it gave us this and said 23 terms, find the partial sum. But the question gives us these digits as part of the partial sum, and it says find the partial sum when there are digits here that are missing. Okay? So if we had the digits included, then we could just add them and find out what the partial sum is. But they're missing. But the good information that we have that it's that we're dealing with an arithmetic sequence. Arithmetic sequence here. Okay? That's important. So our objective, before we apply this partial sum formula, is to figure out what that n is. We need to figure out how many numbers we're adding. Okay? So that's the digit that we're missing. So we have two formulas. Let me make a note here that first, it's not clear how many numbers n we are adding. We just know the first digit, the last digit, and a few numbers in between, but not all numbers. And also that this is coming from an arithmetic sequence. So we need to find what n is. Therefore, or thus, we need to figure out n. Okay, let's see how we can figure that out. Well, let's see if we can use the first formula or the nth term of a sequence formula to find that. Because we know that last digit, we can take it as an. The last digit is 30, right? We know the first digit is -3. And we know the d, we can calculate d very easily. We can take the difference, right? I can tell you already it's going to be 3/2, because you can say 0 minus -3/2, it's going to be positive 3/2. So right there we know what d is. So we know everything in this formula except n. And we can figure that out. We can figure out from the first digit to the last digit in this set of numbers we have, how many numbers exist there using this formula, and then plug it in here. So let's do that. So using let me move this up a little bit. Using an equals a plus n minus 1 times d, we have 30 equals a, which is -3 plus, I'm grabbing all these numbers from this list up here. Like that, maybe I should, like that. So now you can see them. So 30, that was an, -3, that's the first digit. N we don't know, we're solving for that. And d is, of course, 3/2. So d, let me put that here. D is equal to, we can calculate it very quickly, 0. I'm just picking, you can pick any of these numbers. You can pick these two. These two are the easiest probably, these two. 3/2 minus 0. 3/2 minus 0 is equal to 3/2. So d is equal to 3/2. All right? D is equal to that. Okay, so let's plug it in here. We have that times 3/2. Okay, so we have here an equation with only one unknown, And we can easily figure that out, right? So 30 equals minus 3 plus 3/2 n minus 3/2. I just distributed this into that. So let's move all the constants to one side and all the term that has a variable in it that we're solving for to one side. I'm going to keep this on this side. So I kept it positive, so I didn't move this. But I'm going to move 30s on the other side positive. So I'm going to move the negative 3 to the other side. It becomes positive. I'm going to move the negative 3/2 to the other side. It becomes positive again. So what do we have on the left side? We have 3n over 2 equals, so this is 33, so this is 33 plus 3/2. Take the common denominator, so we have 3n over 2 equals, so taking the common denominator here, multiplied by 2, because common denominator is 2, multiply this by 2 over 2. So then on this side we have 2, and then we have 66 plus 3. And so we have 60. So this works out nicely, because if the two fractions on these two sides are to be equal, their denominator is equal. So if the two fractions are to be equal, the numerators have to be equal. So therefore, we can write 3n equals 66 plus 3, right? We can do that, or 69. 3n equals 69, and therefore the n is equal to 23. So, so now that way we can figure out that we are in calculating the partial sum that they're asking us to do, we're adding 23 terms. So that was the number that we needed. So, okay, so let's find the partial sum. So this would be S23 equals 23 times the first digit, which was negative 3, plus the last digit, which was 30, divided by 2. So this would be 23 times, that is 27 over 2, right? And so we have 23 times 27 over 2, and we have, you can either leave it like in exact form, 621 divided by 2, you can either leave it like that, or 310.5. Either way is fine. Okay, let me double check that just to make sure that 23 times 27 is 621. So just to make sure. So 23 times 27, yes, it is. Okay, so probably in the online homework management system or Cengage or WebAssign, maybe they, for a problem like this, maybe they'll ask you to enter the final answer in exact form, in which case you would enter it as 621 over 2. But if they don't, if they allow decimal and they say, give the number to 1 decimal place, then you can also give the answer that way. So we finished discussing section 12.2 here, but as a last comment, when I'm making this video, the edition of the book that I'm using has an excellent example on page 796. So for those of you who will see this video much later than the time I'm recording it, maybe in a few years when we're using a different edition of the book, maybe you won't find this example. But those of you who are using this edition, and I forgot what is the edition number, they have an excellent example on page 796. So I want to remind you that please, at the very end of this, please read and understand example number 3 on page 796 of your book. It's a very good example, and I wanted to mention it here for your benefit here. Okay, so thank you again for persisting through this video with me, and for now, have a very nice day, and I'll see you all next time.